Ladies and gentlemen, it's a great pleasure to be here today. And today I will take you for a trip from Antarctica to the moon and then to Mars. Last winter, I went to Antarctica, to the Belgian station that you can see here located on this map with the Belgian flag. I'm a biologist and I'm working at the Belgian Nuclear Research Center. And space and Antarctica have a lot in common. Both are considered as extreme environments, environments where it's difficult for mankind to survive. Let's look at the weather conditions in Antarctica, for example. You can have wind that blows up to 240 kilometers an hour, temperature up to minus 90 degrees. You can easily understand that people, the crew in Antarctic stations, can be isolated, confined for days and weeks and months in a row, like in space. Antarctica is one of the very best analogs, simulators of human space exploration to Mars. Here, that's me, in Antarctica, on the beautiful Belgian Princess Elizabeth Station, located 200 kilometers from the coast. The Belgian station is the only zero-emission station in Antarctica, where electricity, is produced through 9 wind turbines and 200 solar panels. And I was very lucky to be able to go there and to perform studies on human health and to precisely monitor how human health changes little by little, days after days, during a stay in Antarctica. And through these studies and the samplings that we have been performing, biological samplings on blood, urine, heart monitoring, saliva, we can monitor millions of parameters in order to really subtly understand the changes in the human body. Antarctica is thus the very first step to understand what happens when a person, an astronaut, is confined for a very long time in an isolated environment. But we are living in a very exciting period of time where international space stations and space agencies are really gathering together and for the same kind of quest, and they are all aligned in order to go first around the moon, then on the moon itself, and then further away to Mars and maybe later on to Saturn or Jupiter. And this is what we call the Deep Space Gateway Program. This will be the human first spaceship to go to recognize the solar system and to go deep in space. But there is a big concern and a very big issue, and this issue is ionizing radiation, space radiation. Ionizing radiation are types of radiation that can ionize the matter. They can ionize molecules inside the matter and inside our cells, inside our bodies. We don't realize how much here on Earth we are really cocooned. We are surrounded with an atmosphere, and this atmosphere protects us from space radiation and from ionizing radiation, like a layer of 1 meter of metal. And furthermore, we have our Earth magnetic field that stops about 99.9% of space radiations. So we are really cocooned. Radiation has been always present since the birth of the universe. The Earth is radioactive. We are naturally radioactive. What we eat is naturally radioactive. The plants, the animals, the bacteria are radioactive. But it's not harmful. These doses of radiation are extremely low, and life has evolved with this ever-presence of very low level of radiation on Earth. But let's move, let's quit the Earth, and let's see what happens on the International Space Station, for example, at 300, 400 kilometers in orbit around the Earth. What do we have there? Our physicists from the Belgian Nuclear Research Center have measured and characterized radiation inside the ISS. And they estimated that the dose of radiation is about 150 times higher than on Earth. They placed radiation detectors inside the ISS and also outside the ISS, whilst we, the biologists, are measuring the impact of this cosmic radiation on the health of the astronauts. And we get samples from these astronauts before they go to space, and then 6 months to 1 year later, when they come back from their trip to the International Space Station. And we measure how their cells can repair DNA damage induced by space radiation. And we see that each astronaut has got a different individual susceptibility towards radiation, a different radiation tolerance. And whilst our microbiologists are also preparing flight to Mars inside the International Space Station. And earlier this year, we flew the first bioreactor containing a bacteria called Spirulina, Arthrospira. And this Arthrospira is a beautiful cyanobacteria that can use photosynthesis, that can perform photosynthesis, it can produce oxygen as well as food. So our microbiologists are working on different ways of using bacteria in order to recycle organic matters, purify urine, produce oxygen, and produce food. And this is what we call the Melissa loop. And this is a very important program from the European Space Agencies. Later on, when we will go to the moon, we leave from the ESS 300 kilometers from Earth to the moon, 380,000 kilometers from here. There will be no magnetic field. There will be no atmosphere. So the dose of space radiation will be much higher. But the moon will be a very important step for us and for mankind in order to test and to be a springboard, testing board, in order to make sure that everything is going fine in order to go to Mars. And this is also where we will test different shielding material. How can we better protect mankind and the moon village that you can see from cosmic radiation? And thereafter, we'll go to Mars. This is then 225 million kilometers from Earth. Why do we want to go to Mars? Mars is the closest planet in our solar system, closest to the Earth. It's also the most similar to the Earth. It was warmer once there, and there was water. So it's important to see whether life has also existed there in order to understand how life started on Earth. But if we look at the dose of radiation, I mentioned on the ISS, you will have 150 times more radiation than on Earth. On the moon, 300, 400 times more radiation than on the Earth. On Mars, we'll have, for a trip to Mars and back, 1,000 times more radiation than on Earth. So it's very important to devote some energy and to perform research in order to understand how we can better protect our astronauts. But let me define the 3 types and categories of radiation and space radiation. First, we have the solar wind. The solar wind is not so harmful. It's a continuous flux of low-energy particles, and it can be stopped very easily by the spacecraft skin. However, sometimes we have solar particle events. These are storms of really high energetic particles, electrons and protons. This is an intermittent flux of radiation, but that can be deadly. And usually, the astronauts know a few minutes, a few hours before these storms are really coming towards the spacecraft in order to shield themselves, to go in a protected part of the spacecraft. And then we have the galactic cosmic rays. These galactic cosmic rays are a very big concern for us because we can't stop them very well. So far, all the technologies that we have developed and the shielding that we have found out and developed is not so efficient. And these galactic cosmic rays are high energetic particles like protons, like alpha particles, like heavy ions. And when they come and penetrate inside a spacecraft, they emit a myriad, a shower of secondary particles that will themselves irradiate much more. So it's very important to understand and to block them and to stop them if we want to go to Mars. When a cell is irradiated with radiation, ionizing radiation, you can see here on the left a normal cell on Earth, a cell which is stained with the nucleus appearing in blue. In the middle, you can see a cell irradiated with a high dose of irradiation in order to kill the cell, like in a radiotherapy treatment, when we want to kill cancer cells. And you see the spots inside the blue nucleus that corresponds to the location of the DNA damage. But when you see that when we irradiate with galactic cosmic rays, like iron ions, the damage, the spots are much higher, much more complex. There is much more damage for the cell to repair. And so there is a higher risk that the cell is going to misrepair, not repair completely and fully the DNA damage. And this is a very high risk thereafter to have an induction of diseases like cancer or other degenerative diseases. So for us scientists, it's very important to think outside the box and to develop ways in order to protect the best way we can astronauts in view of their trip to Mars, but also with a direct benefit on Earth. One of the first ways is to increase our shielding material, test different material properties in order to see what is the very best that protects the very best against galactic cosmic radiation. Another way is to select astronauts for the ones that are the most tolerant towards radiation. And this is what we see already in our studies on the ISS, that every astronaut has got a different radiation susceptibility. Like in our population, 5 to 10% of the people are really radiation resistant, whilst 5 to 10% are very sensitive. Understanding what are the parameters that makes this radiation sensitivity is crucial in order also to adapt radiotherapy treatment to even better cure from cancer. Another way is to develop and study powerful radioprotectors. These are pharmacological compounds, substances, medication that can really boost our system, our protective system, and really avoid cells to be damaged in a first instance. And we are studying at the Belgian Nuclear Research Center different powerful and very promising radiation protectors that can be also used for patients in order to protect the healthy tissue and to sensitize even more the tumor before radiotherapy. Another way is to genetically modify astronauts, to somehow modify the genes that are the most important and the most crucial, and that will allow these astronauts to repair very fast the DNA damage and to protect them very much against ionizing radiation. And for that, we have found out about 20 beautiful biomarkers that can very well determine the radiation susceptibility of an individual. Then hibernation. When animals during the winter are hibernating, their metabolism goes much lower. And the fact that their metabolism is slowing down, that increases their radiation tolerance, and they become more radiation resistant. So this could be also a way to boost the radiation resistance of our astronauts. And then on board, to go to Mars, it would be also very good to have the tissues of the astronauts, their cells, in order to regenerate them if needed, if an organ, if a tissue doesn't work very well anymore, to be able to reimplant this tissue, this new tissue working again very powerfully inside the astronauts. So I took you from Antarctica to the Moon and then to Mars. But Mars will not be the final destination, because mankind, through technological advances, through our scientific mind, will always want to make the impossible becoming possible. But before finishing, I would like to bring you back on Earth and tell you that space radiation research has got a tremendous benefit on Earth, and certainly for our cancer patients. If we can understand better the harmful biological effects of space radiation, like, for example, the protons, the heavy ions, the alpha particles, we can thereafter develop even better, targeted, precise, personalized therapies for our cancer patients. And this is extremely important also to develop new radiopharmaceuticals that will kill even better cancer cells. And this is important for our society, and this is also very important for the Belgian Nuclear Research Center to treat better diseases and to cure and save lives even more. And thank you very much, and I hope to see you on the Moon soon.